If you're spending hours every week studying chemistry but still feel like nothing's sticking, there's a reason for that. Most students use study techniques that feel productive, writing pages of notes, rereading textbooks, watching explanation videos, but when it comes time for exams, they realise they can't recall the information when they need it most. That's because studying isn't just about reading and reviewing. It's about actively training your brain to retrieve and apply information. Top students know this, which is why they use a completely different approach to studying chemistry, ones that saves them time whilst making their study routines 10 times more effective. So in this video, I'm going to break down study techniques that will help you retain chemistry content faster so you're not wasting hours on things that don't work. Let's get started. Let's start with lesson 1, previewing your content before class. If you've ever sat through a chemistry lesson where nothing makes sense and the teacher might as well have been speaking another language, it's because your brain had no reference point, so it was trying to process completely new information in real time, which is one of the hardest ways to learn. To make it easier for yourself, here's what I'd suggest you do instead. Before you walk into class, have a rough idea of what's about to be taught. This is called pre-learning, and it's one of the biggest study hacks that help you master chemistry in Year 12. This is because when you expose yourself to new information before your teacher explains it, your brain starts forming connections early. Then, when you hear it again in class, it reinforces those connections, making it way easier to understand and remember. So, how do you actually do this? Let's say your next lesson is on equilibrium and Le Chatelier's principle. The night before, spend 10 to 15 minutes skimming that section in your textbook or watching a short video. Don't try to deeply understand it, just get familiar with the key terms, formulas, and ideas. As you're pre-learning, ask yourself, what do I already know about this, and what doesn't make sense yet? If a concept looks complicated, don't stress. The goal isn't to perfect it, just to see it once so that when your teacher starts explaining, your brain goes, oh yeah, I remember this. If you want to take it a step further, write down 2 or 3 questions based on what you skimmed. Something like, how does temperature affect equilibrium shifts? Or why does pressure matter in gas reactions? Then, when you're in class, listen for the answers. If your teacher doesn't cover them, ask. This does 2 things. Firstly, you're more engaged because now you have something to listen for. And secondly, you retain the information better because your brain is already primed for it. Most students don't do this. They go in blind, get overwhelmed, and then struggle to remember anything later. But if you get into the habit of pre-learning, you'll notice that chemistry suddenly starts to make a lot more sense, as you're not having to constantly catch up on understanding content, but could spend more time applying it. It's a small tweak, but over time, it makes a massive difference. Another small change that made a big difference in my overall understanding of chemistry was converting my study notes into active recall questions. Most students sit in class, write down everything their teacher says, highlight some key points, and then go home and reread them later, hoping the information sticks. I tried this, but it didn't actually help me remember anything in the long term. Think about it. Have you ever read through your notes and felt like you kind of understood everything, but then blanked out when trying to recall it later? That's because reading is not the same as remembering. Your brain needs to be forced to retrieve information in order to lock it into long-term memory. That's where active recall comes in. Instead of just looking at your notes, you need to actively test yourself on them. Here's how to do it properly. When you finish a study lesson, go back through your notes and turn key points into questions. If you wrote down, Le Chatelier's principle states that when a system at equilibrium is disturbed, it will shift to oppose the change. Turn that into, what happens when a system at equilibrium is disturbed? How does an increase in temperature affect equilibrium position? Or what is the difference between a shift to the right and a shift to the left? Now, instead of reading your notes passively, cover up the answers and try to recall them yourself. This completely changes how your brain processes information. Instead of just recognizing facts when you see them, you'll be constantly retrieving and reinforcing the knowledge, which is actually what helps you remember content in an exam setting. If you want to take this even further, especially around exam periods, you can create flashcards where you input your questions and review them using spaced repetition. The key takeaway here is that your goal shouldn't be just to read your notes. It's to make sure that you can recall the information without looking. If you can't explain a concept without checking your notes, you don't actually know it yet. My third tip is to use concept maps and diagrams to visually link complex chemistry concepts. One of the biggest mistakes students make when studying chemistry is treating every topic as if it was an isolated piece of information. I've seen peers memorize chemical equations, reaction types, and formulas separately, without realizing that chemistry is a web of interconnected ideas. If you ever struggle to remember something for an exam, it's probably because your brain stored it as a random fact instead of part of a bigger picture. The solution? Concept maps and diagrams. Your brain remembers visuals far better than words alone. That's why using diagrams, flowcharts, and concept maps can help you see the connections between chemistry topics rather than just trying to memorize them. So let's say you're studying organic chemistry reactions. Instead of just writing a list of different reaction types, draw a mind map with a central node labelled hydrocarbons. From there, you can branch out into alkanes, such as combustion and substitution, alkenes, such as addition reactions like hydration, hydrogenation, and polymerization, and alkynes, which have similar reactions to alkenes, but with different conditions. Then, for each reaction type, add conditions, catalysts, and chemical equations. By the time you're done, you'll have a visual representation of how everything connects instead of a bunch of disjointed facts. This technique works for any chemistry topic. If you're studying acid-base reactions, make a flowchart showing how acids and bases react to form salts and water. If you're learning about redox reactions, map out oxidation and reduction processes alongside their half equations. Concept maps are also powerful because they force you to simplify concepts in your own words. If you can fit an entire topic into a single page and explain it clearly, you can actually understand it. If not, you've identified what you need to work on. The best part is that once your concept maps are complete, you can quickly review a whole unit in seconds by just glancing at your diagram. Instead of flipping through pages of notes, your brain recalls an entire visual structure instantly. This is especially important for parts of the chemistry syllabus where everything is heavily interconnected, such as organic reaction pathways like oxidation, hydration, or dehydration, and identifying unknown substances using chemical tests, either organic substances or precipitate reactions. Mark your past paper answers as if you were a HSC marker. A lot of students write practice answers, glance at the marking guidelines and think, yeah, that looks about right. But in the real HSC exam, looks about right won't get you full marks. High achieving students don't just practice answering questions, they practice scoring full marks on them. The only way to do that is by marking yourself harshly and training yourself to think like an examiner. So when you finish a past paper question, don't just check if your answer is correct. Go through it step by step and compare it to the HSC marking criteria. Ask yourself, did I structure my response properly? And did I use the correct scientific terminology? This is crucial for chemistry marking schemes, as markers want precise wording. Writing, heat speeds up the reaction is too vague, but increased temperature raises kinetic energy, leading to more frequent and successful collisions, is what gets full marks. If a question is worth full marks, an examiner expects at least 2 strong points, elaboration, and relevant chemical equations. Many students lose marks simply by not structuring their answers clearly. You can also ask yourself, did I balance all the chemical equations? If a question involves equations, balancing them correctly is essential. Even if the explanation is perfect, an unbalanced equation could cost you marks. Lastly, did I answer the exact question being asked? Examiners look for specific wording. If a question asks you about enthalpy changes, but you only explain the reaction rate, you won't get full marks, no matter how well you wrote the answer. Once you're compared to your answer to the marking guidelines, grade yourself as if you were an examiner, and be brutally honest. If your response doesn't hit any marking point, deduct marks. It might be discouraging at first, but this is what makes the difference between a Band 5 and a Band 6 response. One of the biggest challenges with marking your own work is knowing exactly how to improve it. That's where HSC Copilot can make a massive difference. Instead of guessing whether your answer is strong enough, you can upload your response, and the AI will mark it based on real HSC standards. This will not only rate your answer, but tell you where you lost marks and where you could have improved, how to refine your structure to make it clearer and more concise, and which key terminology or chemical equations were you missing. This takes out the guesswork and gives you instant feedback, helping you adjust and improve before the real exam. If you start training yourself to mark your work like an examiner and use AI tools like HSC Copilot to fine-tune your responses, you'll know exactly what's required to get you full marks. By the time the actual exam comes, you won't just be answering questions, you'll be writing responses you already know will score top marks. At the end of the day, chemistry isn't just about memorization. It's about understanding, application, and precision. If you apply these strategies consistently, you won't just get better at chemistry, you'll train yourself to think like a top-scoring student and walk into the HSC exam with confidence. And if you want an even more efficient way to improve, using HSC Copilot can take the guesswork out of your exam prep. I've left the link in the bio where you can sign up for free and test it out. Thanks for tuning in, I'll see you on the next video.